Hey guys, I want to introduce you to the next. I want to introduce you to the next presenter, Brad. So Brad is a developer advocate at Google for the open web and gears. As an open web advocate, he is currently focused on increasing the capability of web browsers to render vector graphics such as SVG through drop-in JavaScript shims. He is the creator of a number of libraries and frameworks for expanding the capabilities of web applications, such as Really Simple History and Dojo storage, which I'm sure he will tell you about. He's a core member of the Dojo project, a popular open source JavaScript framework. Brad also created co-working, an international grassroots movement to establish a new kind of workspace for the self-employed. Brad?
Testing. Hey there. So it's really wonderful to be here. I've always wanted to come to Israel. Actually, my grandmother's always wanted me to come to Israel. So it's really great to be here. I got to visit some family in Netanya yesterday, and I called my grandmother, who lives in Dallas, Texas. So I grew up in Texas. We used to say Shalom Y'all. That was sort of the Jewish community there. And I called my grandma, and I'm like, you won't believe where I am. And she's like, what, are you in Dallas? Are you visiting me? And I'm like, no, I'm actually in Netanya with family. So it's a real pleasure to be here. So I actually have two different talks that I can give today, and I like to let the audience decide. So the first talk is an introduction to Gears. We go over all of the different modules that Gears has, with source code, with demos. So you kind of get to see the whole expanse of Gears. Then there's this talk, which is creating a client-side search engine with Gears, which goes really deep around building this example client-side search engine. And you get an introduction to parts of Gears, as well as to Dojo, which we use. So they're both good talks. One is more broad, but not as deep. And the other one's narrower, but much deeper. So I like to let the audience vote. And you only get one vote. We don't have time for both. So just with a show of hands, who wants to see an introduction to Gears? Okay, I won't count. I'll just kind of give a general sense. And who would like to see creating a client-side search engine with Gears? Okay, so it's about the same. So we're going to have to flip a coin. Who has a coin? A shekel. You're going to have to flip a shekel to see which one. Do you have a shekel? That's good. It's a good argument. It does say that. So, I'm not sure what I'm looking at here. Oh, yes. On the one side, we have a menorah. And the other side, we've got writing, Hebrew. So, the menorah is the introduction. And the side with the value is this one. So, let's see. All right, we're doing the introduction. This is it. So that means I have to change the slide. And while I do that, I want to just ask the audience. Chris was kind of asking you in the audience a little bit of these kind of questions, but who here knows JavaScript? Oh, right on. It's amazing. You know, we've had these in a bunch of different countries, but more people raise their hands here. There's more JavaScript experience here. That's great. And who has heard of Gears or worked with Gears? Awesome. Awesome. So many of you might already know these answers, but I just want to explain what is Gears. You know, what are we trying to do with Gears? So the first thing is, in this diagram, we have the browser today, JavaScript, CSS, HTML. And web browsers are on these machines that are unbelievably powerful. Right? They've got, you know, these machines have multiple CPUs, multiple cores, 100 gigabyte hard drives, and yet the web browser doesn't have access to any of these things. It's like making the web be like a Commodore 64, you know? So what Gears does, the idea behind Gears, is to expand what the browser can do in a secure way to really start using the capabilities of these machines that you have, to really expand what the web can do. And a big part of that vision is to do that in as many web browsers as we can. So Gears, as a plugin, hooks into Windows Mobile. It's on Android. It's on Safari, Internet Explorer, Firefox, Chrome. Opera's even working on it. Opera took some of the code and they're bringing it into their browsers. So it's all over the place. And one of the reasons that this is important is I like to ask people, you know, XML, HTTP requests, the magic behind AJAX, when do you think that was invented? In the 1990s. Yeah, so 1997 actually. Actually, Microsoft invented it. And how long did it take until it was in enough web browsers that you could use it and it became widely used? 2005, exactly. Perfect answer. 2005. So if we have to wait close to 10 years for any new thing on the web to be usable by you, yeah, that's not a great situation. So one of the really unique things about Gears is we're trying to take current web browsers and give them new abilities. And a really important part of the Gears vision is that it's open source. This is an open source project. It's an open community. You can get involved. What we're doing is public because we want to raise the capabilities that all developers can tie into, that your businesses can tie into. And like I said, right now we've, you know, the web development platform, things like JavaScript, CSS, HTML. Gears doesn't try to replace those. You can think of it more like icing on the cake. We're just adding some extra capabilities that you can access with JavaScript. We like to call that AJAX++. So some of these modules, and actually the great thing about the introduction is we're going to get to go over almost all of these. You're going to get to see real code. One of them is a database. And this is a real relational database on the client side. It's one of my favorite features of Gears. You can do some really amazing things. Another nice thing is client-side search. So Gears actually embeds the primitives you need to do search on the client side really fast. It's almost like kind of having what Google does, but on the client side, so your web applications can search over data very, very fast. We'll go over that as well today. There's something called worker pools. When you run JavaScript today, it runs in the same thread that the web browser does. And that was OK when JavaScript was just doing some form handling, but now it's doing a lot more, and that makes web browsers go slow. So worker pools are a way to run JavaScript, do hard things with JavaScript, but have the browser stay fast. And don't worry, I'm going to go into all of these. So this is just sort of the high level. And by the way, at any time, if you have a question, raise your hand if you have a comment. There's something called the Desktop API, which is a way, with the user's permission, to drop an icon on the desktop so that they can start your web application the same way they start desktop applications, to make web apps more usable. There's something called local server, and this is the magic behind helping web apps go offline. There's something called blobs, which I really like, and this gives JavaScript the ability to work with binary data. And that goes along with something called the File System API, which allows a user to select multiple files for uploading, and then you use the blobs to do resumable uploading, for example, or to slice it into pieces so that a user can have a good experience when uploading. And we'll go over that. And then one of the parts that I really love about Gears is the Geolocation API. Like Chris mentioned in the keynote, this, with the user's permission, allows you to get the latitude and longitude, turn that into a real location, so you can build web-based applications that are location-aware. If you're using OpenSocial, for example, you could also make them socially aware. So we're really expanding what you can do in the browser. So let's get started. We're going to go over each of the modules. Let's jump into the database module first. So the database, this is local SQL storage. Who here uses SQL today? Nice. So all those skills you have with SQL, like MySQL or SQL Server, you can now use that on the client side. Gears embeds an open source project called Sqlite. Sqlite's really amazing. It's been around for many years. It's actually embedded inside of Mac OS X. Who has an iPhone in their pocket? Yeah, you have Sqlite in your pocket right now. It's on the iPhone, it's in iTunes, it's all over the place. It's open source, it's small, it's only 340K, and it's very fast. What's very cool about it is it's a full-featured relational database. It's not sort of a toy database. You can do virtual tables, triggers. You have a large set of SQL. And it's really stress tested. I mean, you can really put a lot of data in here if you need that, right? iTunes obviously puts a lot of data, and it really stresses it. So you can do those kinds of things in your web app. And a common question is, what about security? Well, the database in Gears is the same as other parts of the web, known as the same origin policy. So if I have one website and I write into the database, another website can't read it. Same way as cookies. So it's exactly the same way. So there's no new security issues. You know, in any web app, you need to make sure you're careful with user input. And the same situation holds here. So there's no new attack surface. So let's jump right into some code. So this is JavaScript. For all of the Gears modules, you'll see the way we generally begin is we call a factory, and you give a name for the module. So it's the database. So right now we're in beta, so it says beta.database. Then you have to open your database, and every database has a name. We're just calling it database-test. So you could have multiple databases for one website. Let's say you've got a CRM application, so you could partition your data that way. And then creating a table is, the same SQL you already know. So here we are creating a table if it doesn't exist, named test. We're giving it 2 columns, a phrase column that's just text, and then a timestamp that's an integer. So very straightforward. Here we are inserting a value. So we're inserting into that new test table 2 values, and you put question marks for where you want the values to go. And then you provide an array that fills in those values. So we're putting a monkey for phrase and a time for the timestamp. So I'd like to ask the audience, why do you think we use question marks here instead of building up a giant string where we paste together, right? Maybe we would say like plus our various values. Why do you think we don't do it? SQL injection attack? Yeah, that's good. One thing to know, though, is on the client side, SQL injection attacks, you're not really protecting against that because everything is untrusted on the client side. Remember that just because you're storing data on the client side and you play it back to a server, you should still validate that data on the server side. The real reason is escaping. What if one of these was a variable and it had a single or double quote in it? And you built up a big string and there was a single or double quote, well, it would break. And because JavaScript is a dynamic language, you don't want to have that happen at runtime. So this is just a nice defensive programming, just to make sure that if there's user input, they build it up. Getting data, straightforward as well. Here we are selecting everything, so you call the execute method, selecting everything from the test table, ordering by the timestamp, doing descending. So now you start seeing real SQL. So you could imagine having this link to a user interface. Maybe the user clicked a button that does sorting. So now you're sorting by timestamp, by descending. So that's nice. And then you get a result set. And we jump to the result set. So while we have a valid row, there we print out the phrase column and the timestamp column. Right there is a Firebug. Who here uses Firebug? It's an awesome tool, isn't it? Yeah, would you let anyone take it away from you? Yeah, exactly. It's a really amazing tool. And then we just jump to the next record. Really straightforward. And then we have a try block and a finally block, which gets run whether there's an exception or not. Why do you think we close our result set and close our database, whether there's an exception or not? What's that? Exactly. This is a good audience. Not to get resource leaks, right. So when you leave the web page, Gears will automatically reclaim any memory you've used. That's fine. But in an Ajax application, generally a user stays on your web page for a long time, right? Like Gmail. And so you can have memory leaks, you know, if you don't get rid of things. When you work with the database, these are real resources. So you should close them. So if the user is, you know, you want them to be on your page for 10 hours, right? If you have some amazing app, that you don't run out of memory. So that's a good best practice. So let's jump right in with a demo. So MySpace actually uses Gears. It's always interesting. I'm always a little, you never know when you sign into MySpace, what you'll see. It's a little bit like Russian roulette. So in MySpace, what they've done is they use Gears in order to allow users to search over their messages. Some users have thousands of friends, thousands of messages, and they're constantly coming in, and they want to search over them really fast. So MySpace decided to use Gears for a bunch of reasons. This is MySpace Mail, and it's kind of like any email system. And right here is a search box where you can type, and it's searching locally using Gears over all of your messages. And it's really fast. So in real time, and of course I can sort by read and unread, who it's from, and so on. Under the covers, obviously, when I'm doing those sorts, those are just SQL expressions. And when it's searching, you'll get to see that's the next thing. It's using the client-side search. And so this let MySpace have some really unique functionality. It's very fast because you don't have network latency. Imagine sending every one of those over the network. And also saves money. Because even if they wanted to do it in real time, they'd have to have some big servers that would, as everyone typed. So this is using the database and the client-side search. So the search, this is really unique. So who here's used Lucene? Lucene? Yeah? So Lucene is a Java open source project. Whenever you want to do searching, you have to build up special kinds of indexes. You take a document, you break it up into words, and you set it up in such a way that you can search very fast. So Google contributed full-text searching ability to Sqlite, just like MySQL has full-text searching now as well. And it's really easy to use. It just feels like SQL, actually, even though under the covers it's not relational. So to set up a full-text search table, you create what's called a virtual table. Here we are making a recipe table that would have some cooking recipes. And then you say using FTS2, that's the name of the module, full-text search, that was contributed to the Sqlite project. And you give the columns that you want to be able to be rapidly searched. And searching is really straightforward. So we say, here we are selecting a dish from the recipe column where we have a recipe that matches this. So we have a question mark here, tomato. So match is the magic keyword. Match will find a partial match across your table. And you can actually get really complex. So here's a fun query. We're saying for the dish column, you have to have the word stew. And then look for the word tomatoes across any column. So you can imagine under the covers, MySpace has tables. One is called like messages, metadata. They just made one of these that indicates that who sent it is searchable, the date, the content of the message. And as you're typing, it's just basically calling this kind of query, match on the word hello. So again, it's really straightforward. So before we jump on to the next module, are there any questions about those two? OK. Oh, that's right. I want to show you one more. I'll show you one more demo. OK.
What do you have to do in order to implement it? Is it just an include phrase, or do you need something else in the client?
So the question is, what do you need to do to implement this?
Yeah.
So it's JavaScript, so use JavaScript. There's a file called gearsinit.js that's on the Google website. All that does is sets up the gears object. And then you can detect for the presence of gears. And we generally recommend that you don't force users to use gears, make it a nice upgradable feature. You'll see that. I'm going to show you a demo with WordPress. Make it degradable. So like MySpace, for example. You can still access your messages if you don't have gears. But if you don't have gears, it says, click here to search over your messages really fast. So it's nice. Doesn't get in the user's way, but it's helping them. And then when you click that, it'll install gears. And if gears is there, you just start using this. You should use the worker pools as well, which I'll talk about. That can really help.
I'm writing applications not for PC, for set-top boxes. So
For what?
set-top boxes.
Set-top boxes.
Set-top boxes.
Cellular or set-top?
Set-top.
Like cable. Set-top. Yeah. Uh-huh.
So the question is, can I use it no matter what set-top box I use?
So the question is, you want to use it in a set-top box environment. It depends if it's running. So I should say Gears runs on Linux. It runs on Mac OS X. It runs on Windows. So if you're running Linux and you have Firefox on there, and that's your environment, you could do that. Or if it's Windows and you have ISO, it depends. I mean, if you don't have one of those environments, then you can't.
But I can use it seamlessly without installing any third-party.
Yeah, if you control the set-top box environment, of course, you could make sure the Gears is already there. Cool. So I want to show you PubTools Search. This is just similar to the MySpace work. This is actually the demo. Oh, see that real quick? It'll disappear. OK. PubTools Search is this drop-in open source JavaScript library. It's actually what the other talk is about. And you can grab this and use this as source code for your own projects to base them on. And what it does is it takes a bunch of URLs. In this case, I've taken a bunch of books from Project Gutenberg, like Montaigne, Goethe, and it's indexed them into Gears so that you can just type and search real time. So if we type history, same thing. We see Descartes, and there's the book. And by the way, at the very end of this presentation, I'll have a link where you can download the presentation with all the URLs. So if you want to grab this source code. And again, you can use this for your business, this code, to start building your own, something like MySpace. All right, let's jump to the next one. So the local server. So many of you have probably heard that you can do offline web applications with Gears. So local server is one of the big pieces of that. So the database lets you take your data offline. But what about your user interface? Your HTML, your JavaScript, your CSS. So if the user's not on the network and they go to your web application, right? How is the browser going to render the user interface? You could maybe use the cache, right? The web browser cache. But why can't you depend on the web browser cache?
It's not reliable.
Exactly. It's not reliable. Yeah. If you're OK with your app working like 80% of the time, maybe the browser cache is OK. So you could think of the local server like a super browser cache. You can bring things into it, your user interface. You can version them, and they'll always be there when the user goes to it. And you can update it if the user interface changes. So you can think of this as your user interface. What's really cool is it's made for offline, but you can actually use it to make things faster, even when a user's on the web itself. And you'll see a demo of that. So one thing that's really important is once you've captured, and that's the term we use, is capturing. Once you've captured a bunch of URLs into the local server, the browser will serve them locally even when you're connected. So once you pull down your JavaScript, it'll happen locally, even when you're connected. Just like the cache. Exactly, like an extension of the cache. And there's two entry points. One is called resource store. This one's simpler, and you just give it individual URLs. Say, hey, capture this. The other one is called managed resource store. And in this one, you give it a file, a list of URLs, and a version. And we actually recommend that you use the managed resource store because it's much more reliable, because it helps you handle versioning and so on. And what you give it is you give it one of these files called a manifest file. It's written in JSON. Who here knows what JSON is? Yeah, awesome. It's basically just JavaScript. Here we are giving two URLs. So we're saying capture this HTML file, and there's that JavaScript file, the gears init.js. And then you give a version. So you could imagine maybe there's like 30 URLs in here, right? The whole UI of Google Docs. You version it. And then you'll see what happens with the code. So you make one of these files. Same thing, you use the factory. There we are, grabbing the local server. Just like a database, you need to open your managed store, and you give it a name, test store. One thing that's unique, we're doing a JavaScript trick here. That's an OR symbol, OR. And what happens is if the store has never been created before, that returns false, and this gets run, which creates the managed store, a little JavaScript trick. What's that? Yes, exactly. So either way, we get a reference to a store. Then you set the name of that manifest file that you just saw. And then you say check for update. And that's it, you're done. And when you call that, what happens is it downloads the manifest file. The first time, it'll download every URL into the local server. Afterwards, at periodic intervals, Gears will re-download the manifest file and say, has the version changed? If it hasn't, everything's fine. If it has changed, it'll efficiently refresh the user interface. Right? So that's how you do the user interface part. And I want to show you WordPress. So WordPress used this in an interesting way. Does anyone here have a WordPress blog? Nice. So WordPress decided to use the Gears local server not for offline, but to make things faster. So users were complaining, you have users when you write blogs, you have an editor, and the editor's pretty advanced, lets you do all sorts of advanced things, but it was taking a long time to load. And so WordPress decided to set up Gears to download all of the admin user interface into the local server so that when you're online, it immediately gets served, and they can control it much better than the browser cache when they push a new version. And what they did, I love what they did. They added a turbo button. Can you see it? I'll put it down here. Turbo. I don't know if the font is too small. I'm blocking it. So turbo. Anyone have an old IBM PC with the turbo button? So this is the turbo button to go from 2 megahertz to 4 megahertz for the web. And what happens when you push it, so the network's doing here. I'm having a nice network timeout here. So I have an empty cache. I actually emptied my cache. So I don't have the turbo button enabled yet. I was going to show you that. So now you get to see, right? If it was enabled, it'd be faster. When you push the turbo button, it downloads 200 of the user interface files for WordPress, and then the editor is much faster. So see, the network's acting up on me. Or someone's downloading a giant movie right now in here. So worker pool. So Brendan Eich, he's the creator of JavaScript. He's always like, we're not going to add threads to JavaScript. And we shouldn't. But one of the issues on the web is, like I said, whenever you run JavaScript, you block the user interface. Has anyone gone to Gmail or a really heavy Ajax app and the browser freezes for a bit? Yeah, right? Worker pools, they're not threads, but what they are, they're a way to run JavaScript away from the browser's user interface. And threads can get complicated because you have shared state. Worker pools, there's no shared state. They can't access the user interface. What you do is you give them some JavaScript to run, and then you send them messages. So you say, hey, run this JavaScript, and you send them a message, maybe with the data. They do their thing, and then they send you a message back. So they send a message back over here. So it's really easy to illustrate this, again, with a nice demo. So in this, we have something that's really intense. We're going to run a prime number algorithm, right? Like I know that actually the Tel Aviv and Israeli computer community is very famous for security, yes? Right? There's a lot of strong security companies here. So you know that prime number algorithms are really heavy. They can be slow. That's the whole idea behind some kinds of cryptography. So we actually are looking for prime numbers in JavaScript. And what I want to show you is when we don't use gears, I press start, and you see prime numbers appear. And we have a little bar here that goes back and forth that just shows as the JavaScript gets more intense, the browser starts getting hard to use, starts getting jerky. However, when we run that same algorithm on a worker pool, it's running, but the browser stays responsive. I could jump around. I could use other web apps. I could even start up another worker. Here we are. So user can continue, but things continue to run. Yes? So the question is, how would that work in Chrome? So one thing that's unique about Gears in Chrome is you don't have to download Gears. It's already built into Chrome. Under the covers, Gears is using the Chrome infrastructure for much of what it's doing. As far as I understand, I'm not completely sure if a Gears worker maps to a thread or a process. So I don't completely know that. One thing that is really unique is, remember I said that Gears is about letting the web do more. If your operating system supports the threads running on multiple CPUs, which almost all modern OSs do, these workers will run on other CPUs or other cores if they're present. So you can actually start to take advantage of the fact that you've got really powerful machines. And OK, how often do you need to compute prime numbers? Not very often. But workers are really important when you're doing a lot of database work. So you want to do the database work on the worker, for example, because if you're hitting the hard drive a bunch and you're searching, hard drives are slow. So MySpace, for example, that stuff all runs on a worker. If you are doing offline, and let's say you're talking on the network to maybe sync, do it on a worker. Again, the user's not blocked. So you can do all sorts of interesting things on workers other than compute prime numbers. I mean, maybe some people in this audience want to compute prime numbers or crack prime numbers. Now let's look at some of the code. I want to show it to you all at once. It makes it easier to understand. First thing, again, same thing. We have the factory. And remember I said that you send messages back and forth? So the first thing you do is we set a message handler on message that will receive the result from the worker. So here we are getting the next prime number. And then you provide some JavaScript that will get run when the worker is executed. So here's a function that would find the next prime number. And then there's a magic method when you're done where you send the message back. So when you're done on the worker, here we are sending the message, result, and that would appear right here. And then right here, there's two ways to make workers. One of them, you pass a big string in of some JavaScript to run. The other one is called create worker from URL. So you could put all your code in another file. We're using the first one here. And we don't want to have to build up a giant string of our code. So we do a JavaScript trick here. Since JavaScript is dynamic, we simply turn the function into a string, which will actually print out exactly what you see there. And then we put a little string here to execute it. And then that's what we pass in. So another JavaScript trick. Yes? Right. So the question is, how can you know how many workers a machine can handle? So you can get up to about 128 workers. But what's interesting is there's a point of diminishing returns. What you actually probably want is 1, 2, or 3 workers. You should have them be long-lived. Don't fire up a worker for everything, and just pass them a message. Generally, 2 or 3 workers. So unfortunately, there's no way to query the capabilities of a machine to the level that you might be asking, like, what's the CPU? The navigator object, which already exists in web browsers, have some of these kinds of information. I think they can tell you the processor model and so on. But in general, you shouldn't be firing off hundreds of workers. It turns out to not be good for performance. Good question. What's that? Yeah, if you launch hundreds and hundreds of workers, you could probably crash the browser. Yes. 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 Unfortunately, Gears does not currently prevent JavaScript from doing a denial of service attack, essentially. Like, for example, Firefox, if there's long-running JavaScript, will say, do you want to kill this JavaScript? We don't have the hooks in Gears, because some browsers are hard. It's hard to know in IE, for example. So we can't offer that. So the desktop API, this one's really simple. It's one method. If you've ever used Google Docs offline, or Zoho, or Remember the Milk, they all use this. It'll ask you, do you want to put an icon? It's one method. Create a shortcut. You give it a name. Give it a URL. Give it a bunch of images of different sizes, because maybe the user has like a giant monitor or a small one. And it will make a shortcut. So if you're on a mobile phone, on Windows Mobile, it'll put the shortcut in the right location. Android, on Windows, it'll put it on the desktop. So it's a really nice way for a user to access your application. And then even though this is a URL, if you've brought that into the local server, the user's going to see your user interface whether you're on or offline. So this is how a user can access your application if you're offline, for example, or if they use it all the time. Like I dragged the Google Docs icon to my dock, so I can always open it whether I'm on or offline. Yes? So the question is, we can cache user interface, but what about actions? So we don't have like an action queue. That has to be at your level. You have to, let's say you're offline and the user's authored 5 email messages. You would just store in the relational database 5 messages. You have a column whether it's sent or not. You could just put unsent. And then when the network reappears, you could resend it. So that would be at the application level. What's that? Yeah, there's some code. If you go to the Gears site, you can detect when a connection appears or disappears. It basically involves you have a background timer that tries to connect. If it times out, it's kind of a philosophical issue whether you're on or offline. I won't get into it. It's kind of an interesting issue. But if you go to the Gears website, there's some good suggestions for how to handle that. Yes?
When will you support interaction with paste?
So the question is, when will we support interaction with copy and paste? Unfortunately, that's not currently on our timeline. But if you're a really good C++ hacker, this is an open source project. That would be a cool piece of functionality. OK, one more question, so I want to make sure we get to all the modules. Yeah? So the question is, does something wrap Gears for GWT? Yes, there is a GWT library that works with Gears. So if you just go to a search engine and type Gears GWT, I think it's just called Gears GWT. It doesn't have a very creative name. But, all right, so the file system. So I'm going to show you a couple modules. And really what they're all about is making the file upload experience better. Chris was saying how at YouTube we were running into this all the time. I'm sure you have as well. Users these days are uploading movies. They're uploading big pictures. It's only going to get larger. And the upload experience in the web browser, it's a little lousy. You start uploading a 100 megabyte file and it just spins. You have no feedback. If it drops in the middle, you got to start all over. You can't do more than one file. Who's ever tried to attach more than one file to a Gmail thing? You have to do each one over and over and over again. So Gears has a couple of things to help solve this issue. One of them is called the File System API. And what this is you just call it, and the user can indicate things. Let's look at some of the methods. So you just call a load files method, and you pass in some options. So you can say whether it's multiple file false to true. You can actually filter as well. You can give a file ending, a MIME type. So you could say only let QuickTime movies be selected. And then it's really straightforward. The user can press Control or whatever the OS is. It's a standard OS dialog. What you get back is an array of file objects. And what these have are two things. One is the name of the file. And for security reasons, we don't give you the full path, because you don't need it. We just give you the file name, right? Because there could be something in that path you don't want to expose. And we give what's called a blob. And I'll talk about blobs. But that's the actual binary content of the thing you're working with. Blobs. These are one of my favorites. Yes? What was that? Yes. Uh-huh. So the question is about file systems. Do we currently embed this in Gmail? Would we embed this in Gmail? Yeah. Yes. Yeah. So currently we're not doing that yet. So I can't talk about future plans, but it'd be nice, right? Since Gears has it. So the blob. I love this. I don't know what this thing is. I don't want to step in it. I like to ask the audience what do they think it is, but. So what these are is, when you start selecting multiple files, you need a way. JavaScript has no way to work with binary data. And a blob is just a handle to the binary data. It's actually efficient. It doesn't try to load the whole thing into memory. It's trying to put a 100 megabyte file in memory. But one of the unique things is the different Gears APIs can take blobs. So you can pass blobs back and forth between workers. So maybe you take one, pass it to the worker, and it starts doing some work on it. And I didn't mention it, but Gears includes an HTTP request module, which is just like XML HTTP request, but with one extra thing. It can send binary data. And we'll put these pieces together. Actually, before we put the pieces together, one more thing about blobs. There's only two things. You can get the length, and you can slice them. So you can take a big blob, and you can slice it into pieces to get another blob. And they're immutable. We don't give you a giant JavaScript array for you to change it. We decided not to do that. We wanted to be very careful with binary data on the client. We wanted to make it locked down by default. So how do we put these together to fix large uploads? So what's really cool is we don't need a special new API. You put these pieces together to do a resumable upload. So you take the slice method, right? File system API, you call it. You get a bunch of files with blobs. You slice it into pieces. And then you call the HTTP request send, and you send that particular slice. And the server can say, hey, I got it, or it times out no, and you can record in the database the last place you were at. So users could resume. So here's some pseudo code of what this would look like. So let's say we want to slice the blobs into 1 megabyte pieces. Let's say we have a resumable upload method where we've already prompted the user and gotten a bunch of files and blobs, and we have an HTTP request. To make this, it's the same as you've seen before. You call a factory method, just like the other Gears modules. And then what we do is we just, by 1 megabyte, we slice the blob, and we send it. If it, obviously there's a lot of code that's not in here, but if it's OK, we go again. If there's a failure, we just try again. And of course, you could link this, because you know where you are in the blob, to a nice user interface. You could have a progress bar. You know the total length of the progress bar. And you just jump forward. And so let's actually see this together. So I've taken this feature of Gears. And I've created something called the Upload Movie tool. This uses Google App Engine for the server side. And it actually uses the Geolocation API as well. And what it allows you to do, which made sometimes on these private networks, it can have a little trouble. Oh, but it got it. Look, no. That's probably a bug in my code. Never seen that before. Oh, OK, this is what this is. So the Geolocation API can let you turn a latitude and longitude into a location. But I don't think we've got that for Israel. So a particular street in town. So that's what those say right there. So I've put together the pieces you've seen, and I have the geolocation to tag, like to geotag it from where it came from. And you'll see these pieces come together. So we can say select. So here's the first thing. We can select multiple files. It's amazing, right? You couldn't do that on the web. Select multiple files. We see it here. Unfortunately, it's geotagging it a little incorrectly because I don't have a town and street here. But you see how much is uploaded. We can start to upload it to the service on Google App Engine. I think things are pretty slow here. And Murphy is loving me today. So the network went down on me again. So I'll have to paint with pictures. It didn't even get a chance to send one chunk. At least you would have seen a 5%, and then would have sat there and tried to resend it.
Smaller chunks.
What's that?
Smaller chunks.
Yeah.
It's very low.
There we go. Look at that. You see that? It did it. It resumed. Probably got an error and retries 3 times for each chunk. And then I paused it, actually. So now it'll continue. It seems like there's a lot of latency right now. And they're kind of small, simple movies. We'll see if it can download the movie from Google App Engine. But again, this code is open source. It's a really nice template if you want to use the App Engine. It also has all these pieces together if you want to use the JavaScript. So you can use that in your own project if you want to do uploading. I apologize for the network. What's that? So I'll give you, well, uploadmovietool.appspot.com. You can actually just view source. I think I have a link to the project as well. But at the very end, I'll give you a URL. You can download all these. So let's look at the final module. This one's really fun, the Geolocation Api. You've kind of gotten a sense of this. What this does is it lets a web app in a really straightforward way get the latitude and longitude if the user gives permission. And you also get an accuracy. And what's really cool about it is under the covers, it will figure out the best way to achieve this. If you're on a mobile device and you have GPS, it'll do that. If you're on like Android, for example, and there's cell phone towers, it'll use that. If you're on a laptop machine, it'll use the IP address, or it'll do some tricks to try to figure out from Wi-Fi networks where you might be. At the end of the day, you get back a latitude and longitude and an accuracy. One thing that's really cool is it also has what's called reverse geocoding, which sounds like a lot, but that's just a fancy term for turning a location into a real place. So that's what you saw. So in my code, I should have checked, do we have a street name? Do we have a city? So you can turn it into that, at least at the country level generally. And then you could do something interesting, right? You could have a map that you populate with hotels. You'll see in this demo. So the code is really straightforward. Again, the factory, getting the position. We can get it once, get the current position. We have a function that gets called, and you get a position object. And you can grab the latitude and the longitude. And then we're imagining we have an update map method here where you could update a map where your location. But then you could watch your position over time. Like let's say you have a mobile device and you want to just leave it on as you walk through the city. And that's called watch position. Same thing, you'll get called at regular intervals with the location, and you can clear the watch when you're done. So super straightforward. Position object has other stuff on there. You don't necessarily have to use it. There's your latitude and longitude. You can get an altitude. So if you're near the Dead Sea, you can find out, you'll probably get a negative number. You can get accuracies and a timestamp. And then it's not up here, but you can also get the actual physical location like I mentioned. So again, let's cross our fingers for the demo folks. I'm going to have to describe this to you, unfortunately. So last minute, they've taken this feature, they have these maps. And so what you can do is when you go into a new city, you might want to know what are the best hotels, what are the best restaurants. You click a button, figures out your location, drops it on the map, and says, here's 5 good hotels, here's 5 good restaurants. So, you know, it can really start making things easier. So you see the map. It says, click here to get hotels near you. So depending on the environment, GPS devices can sometimes take 10, 20 seconds. IPI, here we go. Got it? So the network has a lot of latency, so it's just trying to update. And it's slowly showing Tel Aviv there. And then it has a little icon for locations of different hotels that are recommended. And there's some hotels that are recommended right here. So it's pretty cool. So it's a nice feature. So let me put up. So I want to jump up. So are there any questions? Here is the URL, tiny URL, to download the slides. And what are some questions you might have? Yes?
Going back to the MySpace example.
Yeah.
I'm sure synchronization is a very common problem for Fusion for years and changing.
Yes. So the question is, syncing is probably a pretty standard thing. There's some libraries. Gears doesn't provide synchronization help. I have a library I made called Dojo Sync. It's part of something called Dojo Offline. If you go to the Gears site, it's gears.google.com. You'll see a lot of documents that can help you with syncing. Syncing can actually be really easy depending on what you choose to try to solve, or it can be really hard. We go over that. So Gears itself doesn't provide services. It's actually, mini apps are quite different, actually. Yeah. Question, do we have any statistics on adoption? We don't give out numbers, unfortunately. But it's being adopted by some big sites, WordPress, MySpace. It's being deployed across our large-scale things like Google Docs and Google Reader. So we're having really nice uptake. But we, unfortunately, can't give out actual numbers. Yes?
You were talking about the possibility to store files locally. For how long?
You talked about the possibility of storing files locally. So there's different things. So you can store data in the database. That's forever.
The server files like JS or HTML files.
So the local server, they'll always be there. You don't clear it from the cache. Your application can clear it. The user can there's a new pull down. They can take away permission for your site to use Gears, but they don't time out. There's not a timeout. So the question is if you change them on the server. So that's the idea behind the manifest file. When you change them on the server, just change your version number in that file, and Gears will see that and get the new changes. Huh? So the question is, can Gears connect to gadgets? So gadgets doesn't necessarily have support for Gears, but Gears is just a JavaScript API. And you could, you could start using it if you wanted to as an optional feature. Just like you would like you could use another JavaScript library, for example.
Modern browsers such as Firefox 3.1 implements HTML5 standard.
Yes.
Same features rather as Gears today.
Yes.
Do you plan making Gears compatible with standards?
So the question is, Firefox 3.1 implements newer features of something called HTML5, the new version of HTML. I didn't mention it. What's really cool is Gears and HTML5 work together. So a lot of the things that you've seen in HTML5 were written up by the Gears team as their experience, like the SQL storage. And over time, you'll actually see Gears becoming a cutting-edge implementation of HTML5, a way to get HTML5 out there. So for example, Firefox 3.1 is implementing the geolocation, which was written by one of the Gears team. So our attitude is we're not trying necessarily to get gears everywhere. It's more about getting these features. We want to help grow the web. And so whether that's through HTML5, with like storage, so our goal is just to help grow the web. So it's a good question. Does that answer your question? So one more question. Oh yes, and I want to say you've got these forms to grade the talk. Be honest. I hope you enjoyed yourself. If you have more questions, just come up to me afterwards. I have to run quickly, unfortunately. But what's that? I have to go really soon. But thank you so much for your time.